Good morning. My name is Dr. Joel Shertok, and I'm president of Process Industries Consultants, a chemical engineering consultancy located in Newark, Delaware. Today, I'd like to talk to you in an introductory way about the field of specialty chemicals, a specific niche within the chemical process industries. I love specialty chemicals. I spent all my career, stretching back to 1975, working and optimizing specialty chemicals. And you say, well, gee, Joel, what's a specialty chemical? Well, a specialty chemical is a material that's sold in small volumes but very high margins, as opposed to a commodity chemical like polyethylene, which is made in the millions and millions of tons, but whose profit margin is very small. Specialty chemicals are interesting because a small amount of process improvement can yield a fair amount of profitability dropping to the bottom line. So, as a chemical engineer, when I was working for industry, I was always concerned with how do you squeeze more dollars out of your plant. Constant assignment that I always received was, gee, Joe, we've got this plant. It's doing okay, but it's not doing as okay as we wanted. What can you do? So let's talk a little bit about the whole world of specialty chemicals and talk about how one goes about optimizing a process. So you have a specialty chemical plant. It's making polyvinyl acetate. It is making prepreg composites. It is making a specialty resin. What does one do to improve profitability? And for those who are interested, I cover this in my book, The Art of Scale Up, which I'd be pleased to provide it to you at no cost. Just let me know. So you're looking at a plant, and you're saying, no, what do I do? Where do I start? How do I optimize it? Plants, by definition, have two cost centers, people and raw materials. It takes you a certain amount of time to make a product. It takes you a certain amount of raw material to make a product. If you can decrease the amount of time and the amount of raw material you use to make a given pound of product, or adapt your plant to make a more profitable product, you're on the way to improve profitability. So what does one do? A source of information that is often underlooked is the plant log sheets. In other words, the record of all the operations that go through a plant to make a product. This is a really rich source of information that's overlooked. So take a look at the log sheet. Look at the different operations that a log sheet goes through. Look at the time it takes to do a reaction. Look at the time it takes to do a purification. Look at the time it takes to do a cleanup. If you can impact that to get more material through in a short amount of time, you're making more money. Look at the amount of raw material that goes into a plant versus the amount of product coming out of the plant. Every incremental change you make will make that plant more profitable. So let's talk about some examples. I started my career working for Union Carbide. And one of Union Carbide's products was a polyvinyl acetate polymer. Nothing fancy, just a polyvinyl acetate polymer. And it went to chewing gum. Now, does anybody listening to this ever think much about chewing gum? You put it in your mouth and you chew it and you spit it out. But the reality is, chewing gum has a very complex formulation. It contains natural products, artificial products, flavoring, sugar. It has to feel just right in your mouth. If it's too hard, that's no good. If it's too slimy, that's no good either. If the taste is over too fast or it's too sweet, that's no good. It has to be a very complex balancing of properties. So there's a certain standard polyvinyl acetate that goes into your standard chewing gum. The big revolution in chewing gum came when they created something called bubble yum. And bubble yum was a soft chewing gum. In other words, unlike the bazooka chewing gum that most of us grew up with, which required 3 minutes of real hard chewing to get it to work, bubble yum was soft the minute you put it in your mouth. The secret was a different sort of polyvinyl acetate. And I was assigned the problem of duplicating a polyvinyl acetate that the current supplier was using in the formulation. And what does one do? Well, you have to simulate the reaction that's used to make polyvinyl acetate. You have to create the conditions that give you a different property, what you're looking for. And then you have to figure out, well, how am I going to separate it from all the garbage that's made during the reaction? That is one of the keys to improving your, the position of your specialty chemical plant. Make a new profitable product. And we were successful. We did something on a pilot scale. We made a couple of pounds. The customer loved it. Went there on the production facility. We made 10, 15 drums. Customer loved it. And we had a commercial product. That carbide could sell at a profit. Another interesting problem was making a material that was a solid, and the customer wanted a liquid. How does one create a liquid from a solid compound? A matter of manipulating reaction, reaction time, et cetera, et cetera. Again, a new profitable product. But let's talk about how do we vary conditions, how do we read a log sheet to keep the product the same, yet make more product in a more profitable way. So as an example, one project I'm working on now involves a very high temperature lubricant, and the plant can sell every pound they make. They want to make more pounds, obviously. So given that problem, what does one do? Well, you look at the log sheets. Where are things taking time? Well, first of all, the reaction takes too much time. Why is it taking so much time? They use tons of catalyst. Why are they using so much catalyst? The distillation process for purification takes way too much time. Why is that? So by asking why and why and why, and using chemical engineering principles, one can then go back into the plant and say, where is the problem? Why are you using so much catalyst? Why is it taking so much time? What new operations can you use? And you basically let the project speak to you. That's the most important thing. Every process is telling you things, and if you're only smart enough or clever enough to understand what's telling you, you are on the road to success. So if, as a specialty chemical manufacturer, you are under increased competition every day today. The market, as we know it, came to an end in the early 1980s when the Japanese came on the scene. The Japanese basically showed how you can make specialty products with improved quality and lower price to make more profitability. And that started a panic. So let me give you an example. We made a certain product called caprolactone that was used in a wide variety of different polymers, but especially used in the coating industry. We sold a lot of caprolactone as a union carbide company to automotive coatings, and they loved it, except there was only one problem. When the formulation was used, it turned a beautiful, beautiful Kelly green. It would cost you millions if you wanted to make it deliberately. We made it as part of our process. And we were able to convince the manufacturer that this was a consequence of caprolactone, couldn't help it. And they bought it. Until the Japanese came in and gave them a caprolactone that did not turn color. And the company said, hey guys, you duplicate this, or else you're giving all your business to the Japanese. So as part of a crash program to get rid of that yellow color, which required a green color, which required different reaction train, different distillation train, but this saved the business. And every specialty chemical manufacturer, every day, is going through this exact same operation. They are facing increased competition. They're facing increased consolidation. Inflation has hit their profit margins. So the understanding of your basic chemistry and your basic process is more important than ever. And let's face it, as a specialty chemical manufacturer, you are facing competition for the big boys, BASF, Dow, Laxness, any number of big companies that have a vibrant specialty chemical business. You are getting competition from EPA, you're getting competition from REACH, you're getting competition from the Europeans, all for improved safety and safe regulatory. In addition, there's increased pressure for green chemistries. That was not an issue when I started business. No one heard of green chemistries. But today, doing work in a sustainable manner is becoming more important than ever. And especially chemical manufacturer, you are under all these pressures every day. How can I be greener? How can I be cheaper? How can I get my quality up? And as a chemical engineer, consulting and in my past, this was an extremely important criteria that basically keeps me in business. Now, what can we predict? I think we're very safe in predicting that things will not get any easier as time goes on. Just read the papers. Oil supply is uncertain. Energy supplies are uncertain. There's a profound revolution going on in the way that we get our energy. The old days of oil-fired or gas-fired distillation columns are coming to an end. And we're approaching both the electrical era and the hydrogen era, all of which will have profound, profound implications on specialty chemical business. So if you look at the specialty chemical business today, we can see that process knowledge, process optimization, and process imperialist is really the way we need to go. We need to more and more understand what we're doing, how we do it, and where we're going to go in the future.
So if people want to get in touch with you because they just heard all this and they're like, this guy is really goddamn smart, I need to hire this guy, how do we get in touch with you?
So to get in touch with me, you can contact me at my website, which is Shertok, Shertok, at process, Process, ind, consultants.com. Or you can call me on my cell phone, 1-302-562-9759. And by all means, please check out my website, www.processindconsultants.com, and please check out my LinkedIn page. Thank you very much.